So far in this lecture, we have considered in logistic regression, we have a dataset D, which is a set of m data points xi and yi, where I goes from 1 to n, and each of the xi's is a k-dimensional real vector, and each of the yi's is binary. Furthermore, we have a basis function, a feature function phi, which takes an xi, and it maps a k-dimensional real vector to some n-dimensional real vector, which is perhaps a nonlinear representation of the input data points xi. So we also consider that the function that we are going to use for learning the mapping fw of phi of xi is a logistic function which is e to the power negative of phi of xi transpose times w. And as we showed in the earlier part of the lecture, we'll use it to directly learn the conditional properties, that is g of phi of xi transpose w models the conditional property as p of yi given the xi and the distribution is parameterized by the parameter w, the learnable parameter. So before we learn as to how to compute these parameters w, let's look at some of the properties of this logistic function, right? So first we'll compute its derivative, which should be useful later in this lecture for computing the maximum likely estimate of this parameter w. So let's compute the derivative of the function with respect to its input, where t is a scalar, right? So we'll compute this derivative with respect to its input or argument, which is equal to so we just use basic calculus to compute this derivative. Which is equal to so we can further simplify this. So this is equal to times so this is g of t so this becomes g of t times so we'll simplify the term in the bracket by adding 1 and subtracting 1. So we get this, which is equal to g of t times 1 minus g of t. So the derivative of the function We'll denote it by G prime T, is simply G of T times 1 minus G of T. So we are going to use this in the derivation when we compute the solution for the W. So now let's compute these parameters W so that we can learn this functional mapping which models our conditional probability distribution. This P of yi given xi and distribution is parameterized by the parameters W. So let's see how to compute this function.